Hello everyone, welcome to our YouTube channel Science Pathashala. Dear KAR-TET 2025 aspirants, this video is made especially for you. Today we are going to learn one of the most fundamental scoring and most expected topics: atoms, shells, electronic configuration, valency and the octet rule. ನೀವು ಈ ಬೇಸಿಕ್ಸ್ ಅನ್ನು ಒನ್ಸ್ ಸರಿಯಾಗಿ ಅರ್ಥ ಮಾಡಿಕೊಂಡ್ರೆ ಕೆಮಿಸ್ಟ್ರಿ MCQs ಎಕ್ಸಾಮ್ನಲ್ಲಿ ತುಂಬಾ ಈಸಿಯಾಗಿ ಸಾಲ್ವ್ ಮಾಡ್ತೀರಾ. ಬಿಕಾಸ್ ಫ್ರಮ್ ಬೋರ್ ಬರಿ ರೂಲ್ಸ್ ಟು valence electrons, every concept is directly connected to the MCQs. In this video we will understand how electrons fill shells, how to write electronic configuration, what makes an atom reactive, why elements gain or lose electrons, ಮತ್ತು octet rule ಯಾಕೆ ಅಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್ ಅನ್ನೋದನ್ನ. So with the simplest explanations and real examples that you will remember forever. At the end I will also give you KAR-TET previous year questions so you can see how this exact concept appeared in the real exam. So watch till the end friends, because this one video will make atoms, shells, valency, octet rule super clear and exam ready. So let's begin our journey towards KAR-TET success with Science Pathashala. So let us start today's session. Matter is everything that occupies space and has mass. Simple example, the pen you are holding, the air you breathe, even the water you drink, all are matter. ನಮ್ಮ ಸುತ್ತಲಿರುವ ಎಲ್ಲವೂ ಮ್ಯಾಟರ್ ಆಗಿದೆ. So scientists always wondered, what is matter made up of? Is it continuous or is it made up of small particles? ಈ ಪ್ರಶ್ನೆಗೆ ಆನ್ಸರ್ ಹುಡುಕೋದಕ್ಕೆ they started doing experiments and finally discovered that matter, it is made up of tiny particles. They are called as atoms. Okay, matter, it is made up of the tiny particles which is called as atoms. So now the problem was nobody had ever seen an atom. It's extremely small, so scientists had to imagine and propose models. ಸೊ ಅವರ ಕಲ್ಪನೆಯ ಆಧಾರದ ಮೇಲೆ ಅವರು ವಿಭಿನ್ನ ಅಟೋಮಿಕ್ ಮಾಡೆಲ್ಗಳನ್ನು ಸಜೆಸ್ಟ್ ಮಾಡಿದರು. ಈಚ್ ಮಾಡೆಲ್ ವಾಸ್ ಆನ್ ಇಂಪ್ರೂವ್ಮೆಂಟ್ ಓವರ್ ದ ಪ್ರಿವಿಯಸ್ ಒನ್. ಜಸ್ಟ್ ಲೈಕ್ ವಿ ಅಪ್ಡೇಟ್ ಅವರ್ ಮೊಬೈಲ್ ಫೋನ್ಸ್, ಸೈನ್ಸ್ ಆಲ್ಸೋ ಅಪ್ಡೇಟ್ಸ್ ಇಟ್ಸ್ ಐಡಿಯಾಸ್. ಹಳೆಯ ಮಾಡೆಲ್ನಲ್ಲಿ ಇದ್ದ ಲಿಮಿಟೇಷನ್ಸ್ ಅನ್ನು ಹೊಸ ಮಾಡೆಲ್ ಕರೆಕ್ಟ್ ಮಾಡುತ್ತಾ ಬಂದಿತ್ತು. ಅಟಾಮಿಕ್ ಮಾಡೆಲ್ಸ್. ಸೊ ಡಾಲ್ಟನ್ಸ್ ಅಟಾಮಿಕ್ ಮಾಡೆಲ್, which was discovered in the year 1803, which is also called as billiard ball model. So Dalton said atom, it is a small solid indivisible particle, as we can see in the figure. So he assumed atoms of each element are identical. Idu tumba sarala madari because internal structure was not known. So the next model was J.J. Thomson model, which was discovered in the year 1904. So which is also called as plum pudding model. So Thomson discovered the electron and proposed the plum pudding model. So atom is a positive sphere with electrons embedded inside, as we can see in this particular figure. So ಎಲ್ಲ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಒಳಗೆ ಚೆದರಿದಂತೆ ಇರುತ್ತದೆ. ಓವರಾಲ್ atom it is neutral ಅಂತ ಹೇಳಿದರು ಅವರು. So the next is Rutherford's nuclear model, which was discovered in the year 1911. So from the gold foil experiment, he proved atom has a small dense nucleus. So as we can see here, this is the small dense nucleus. So electrons revolve around the nucleus and most of the atom it is empty space. ಇದರಿಂದ atom ನ ನಿಜವಾದ ರಚನೆ ಸ್ಪಷ್ಟವಾಯಿತು. So the next is Bohr's model, which was just discovered in the year 1913. Bohr said electrons move in, what is that? The fixed energy levels or shells. As we can see here, electrons are revolving around the nucleus here. So they absorb or emit energy when they jump between the levels. As we can see here, the electrons can jump between these energy levels. Okay. So ಇದು ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಅನ್ನು ಚೆನ್ನಾಗಿ ವಿವರಿಸಿತು. So the next is Schrödinger quantum model. So which was discovered in the year 1926, electron cloud model. So he introduced the quantum mechanical model. So electrons do not move in fixed path, instead they exist in probability clouds. that is the orbitals. Idu indina modern atomic model. Okay, these are the some of the atomic models which are important for the examinations. Introduction to atoms, matter and atoms. Everything around us, it is made up of matter. So matter, it is made up of tiny particles which is called as atoms. So atoms are the basic building blocks of all the substances. ನಾವು ಕಾಣುವ ಎಲ್ಲ ವಸ್ತುಗಳ ಮೂಲ ಅಣುಗಳೇ. So the structure of an atom. So we know at the center we have the nucleus, as we can see in the figure. In the center we have nucleus which contains protons and neutrons. So protons are positively charged particles, neutrons are neutral particles. So and the electrons revolve around the nucleus in specific shells or orbits, as we can see here. The electrons, they are the negatively charged particles which is just revolving around the nucleus in this particular circular path. Okay, so ಎಲ್ಲ ಕಕ್ಷೆಗಳು ತನ್ನದೇ ಆದ ಎನರ್ಜಿ ಹೊಂದಿರುತ್ತದೆ. So the key idea here, energy levels decide how atoms bond and form molecules. So if we understand atoms, we understand how matter behaves. So ಅಣುಗಳನ್ನು ಅರ್ಥ ಮಾಡಿಕೊಂಡರೆ ಬ್ರಹ್ಮಾಂಡದ ರಚನೆ ತಿಳಿಯುತ್ತದೆ, because everything it is built from what is that? Atoms. So this slide, it is very important from the point of examinations. So subatomic particles, the first is electron. So electrons are very light particles with a mass of 9.109 into 10 raised to minus 31 kg. So they carry negative charge. So the charge here, it is minus 1.602 into 10 raised to minus 19 coulomb. So electrons move around the nucleus in different orbits or shells. So ಅಣುವಿನ ಹೊರಗಿನ ಭಾಗದಲ್ಲಿ ಸುತ್ತುವ ಕಣವೇ ಎಲೆಕ್ಟ್ರಾನ್. So it was discovered by J.J. Thomson in the year 1897. So protons are the positively charged particles and they are much heavier than electrons. So the mass of proton, it is 1.673 into 10 raised to minus 27 kg. So they carry a positive charge. So the charge here, it is plus 1.602 into 10 raised to minus 19 coulomb. So protons are located inside the nucleus, giving the atom its identity, that is the atomic number. So it was discovered by Ernest Rutherford in the year 1917 by gold foil experiment. So the next is neutron, which is the neutral particle. So neutrons have almost the same mass as that of the protons. So here it is having a mass of 1.675 into 10 raised to minus 27 kg. So they are also present in the nucleus and help in stabilizing it. So discovered by James Chadwick in the year 1932. The next is atomic number, which is represented by Z. So it is the number of protons in the nucleus. It determines the identity of an element. Example, hydrogen. So it is having one proton. So the atomic number, it is 1. So carbon. So carbon atomic number, it is 6 because it is containing 6 protons within the nucleus. So the mass number here. So mass number, it is represented by A and it is just written on the top of the element. So the total number of nucleons is nothing but the number of protons and neutrons. So here the mass number, which is represented by A, is equal to the number of protons plus the number of neutrons. The example here, carbon 12. So carbon, it is containing 6 protons plus 6 neutrons. So the mass number, it is 12 here. So we can just write it like this, C6 and here 12. So this is the atomic number, which is Z. So this is the mass number, which is just represented by A here. Okay. So isotopes, atoms of the same element which is having same atomic number but different mass number. So they have the same chemical properties but different physical properties. For example, chlorine 35 and chlorine 37. So both have atomic number 17. For example, I can write here Cl17. Here I have written 35. So Cl here 17, here 37. So here both elements, they are having the same atomic number, but here the mass number, they are different. So if there is a difference in the mass number and same atomic number, they are called as the isotopes. For example, you can take hydrogen also, H11, H12, H13. So this is called as procium, deuterium and tritium. So the atomic number is same, but there is having a different mass number, that is called as isotopes. The next is, dear students, isobars. Atoms of different elements having same mass number but different atomic number. So they are called as isobars. For example, we can take argon. So argon, the atomic number, it is 18 and it is having a mass number of 40. So as we can take calcium here. So calcium, it is having the atomic number 20 and it is having a mass number of 40 here. So here these are the two elements, argon and calcium. So here argon is having mass number 40 and calcium is also having mass number 40. So the element which is having same mass number, but here the atomic number, they are different. So they are called as isobars. Okay. So the next is transmutation, and in the previous year question paper they have asked one question regarding the transmutation. So transmutation is nothing but it is the conversion of one element into another. So it usually happens by the radioactive decay or the nuclear reactions. In the context of isotopes, some isotopes are radioactive and they undergo transmutation. Example, carbon 14, it is unstable. Okay, so just it will undergo the decay and it is just forming nitrogen 14. So here the radioactive isotope carbon 14 changes into another element, that is nitrogen 14. So in simple words, it is a natural process where an unstable atom breaks down on its own and releases energy to become more stable. So ಇಲ್ಲಿ transmutation ಅಂದ್ರೆ ಏನಾಗ್ತದೆ, just they are converted in the form of isotopes. So next is the naming of shells. So atom ಒಳಗೆ, that is ಮಧ್ಯದಲ್ಲಿ ನ್ಯೂಕ್ಲಿಯಸ್ ಇರುತ್ತದೆ. As we can see this, ಮಧ್ಯದಲ್ಲಿ ನ್ಯೂಕ್ಲಿಯಸ್ ಇರುತ್ತದೆ ಮತ್ತು ನ್ಯೂಕ್ಲಿಯಸ್ ಒಳಗಡೆ ಪ್ರೋಟಾನ್ಸ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಮತ್ತು ನ್ಯೂಟ್ರಾನ್ಸ್ ನ್ಯೂಟ್ರಲ್ ಇರುತ್ತದೆ. So as we can see here, there is presence of protons and there is presence of neutrons in the nucleus. Okay, so nucleus ಸುತ್ತಲೂ electrons energy level ನಲ್ಲಿ ಸುತ್ತುತ್ತವೆ ಎಂದು Bohr model ಹೇಳುತ್ತದೆ. As we can see in the figure this. So Bohr introduced fixed energy levels and later scientists gave names to these particular shells. The first orbit, it is called as the K shell, as we can see here in the figure. So the next it was L shell, the next it was M shell and the next it was N shell. Okay, ಅಂದರೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಯಾವ ಮೆಟಲ್ ಅಲ್ಲಿ ಇರುತ್ತವೆ ಎಂಬುದನ್ನು ಹೇಳಲು ಈ ಹೆಸರುಗಳನ್ನು ಬಳಸುತ್ತಾರೆ. So K shell, it is just present. What is that K shell? That is just n is equal to 1, that is it is having lowest energy. nucleus ಗೆ ಇದು ಹತ್ತಿರವಾಗಿದೆ. So next is L shell, that is it is represented by n is equal to 2. The next is M shell, that is represented by n is equal to 3. The next it is N shell, that is represented by n is equal to 4, that is it is having higher energy. So ದೂರ ಹೋಗುವಷ್ಟು ಎನರ್ಜಿ ಹೆಚ್ಚಾಗುತ್ತದೆ. So like climbing to the higher steps on a staircase. So an atom has a nucleus, that is protons plus neutrons plus electrons, which is just present in, what is that, the K shell, L shell, M shell, N shell. The next is atomic shells have a maximum capacity of electrons, and Bohr explained that this depends on the formula 2n square. So here n ಅಂದರೆ it is the shell number, n ಅಂದರೆ it is the shell number. So that is K is equal to 1, L is equal to 2, M is equal to 3 and so on. N is equal to 4. So using the 2n square formula, so we get that is ಇಲ್ಲಿ ಏನಿದೆ shell, K shell. What is the value of n here? It is 1. So it can accommodate a maximum of 2 electrons. How? Using the formula 2 into 1 square. So that is equal to 2 electrons. So now the L shell, what is the value of n here? It is 2. So means 2 into 2 square is equal to, so what happens here? 2 square 4, 4 2s are 8. So 8 electrons. So the next is M shell. So the n value it is 3. So 2 into 3 square 9, 9 into 2 it is 18, that is 18 electrons. So the next is 2 into 4 square. So what happens here? We will be getting 32 electrons. Okay. So ನಾವು ಚಿತ್ರದಲ್ಲಿ ನೋಡಬಹುದು ನ್ಯೂಕ್ಲಿಯಸ್ ಮಧ್ಯದಲ್ಲಿ ಇದೆ, ಅದರ ಸುತ್ತ ಏನಿದೆ? K ಶೆಲ್ ಇದೆ, L ಶೆಲ್ ಇದೆ, M ಶೆಲ್ ಇದೆ, N ಶೆಲ್ ಇದೆ. ಸೊ ಮತ್ತು ಪ್ರತಿಯೊಂದು ಶೆಲ್ ನಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಸೇರಬಹುದು ಅನ್ನೋದನ್ನ ಕಲರ್ಫುಲ್ ನಂಬರ್ಸ್ ಮೂಲಕ ತೋರಿಸಲಾಗಿದೆ. ಸೊ ಶೆಲ್ ದೊಡ್ಡದಾಗುತ್ತಾ ಹೋದಷ್ಟು ಅದರ ಕೆಪಾಸಿಟಿ ಹೆಚ್ಚಾಗುತ್ತಾ ಹೋಗುತ್ತದೆ. ಸೊ ಲೈಕ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಸೀಟಿಂಗ್ ರೋ ಇನ್ ಅ ಬಿಗರ್ ಸ್ಟೇಡಿಯಂ. So we have just saw here a question, how many electrons can be present in the M shell? Directly we can write 18 electrons. Next, Bohr-Bury rules. So these rules helps us to decide how electrons are arranged in different shells. So the maximum electrons in a shell, it is given by 2n square formula. So the outermost shell can have a maximum of 8 electrons according to the octet rule. So the inner shell first fill, okay, that is the first K shell is filling here, next L shell fills, then M shell, then the N shell here. So the example here, write the electron distribution for chlorine. The atomic number for chlorine, it is 17. So to fill 17 electrons, we follow the rules, that is the K shell. So it is having a maximum of 2 electrons. So we put 2 electrons. So L shell, so maximum of 8 electrons. So what happens here? Next 8 electrons. So remaining electrons, so that is 17 minus 2 plus 8, that is equal to 7. So these go to the M shell, that is the remaining 7. So the final distribution for chlorine, it is 2, 8, 7. 2, 8, 7. It is the electron distribution for chlorine. This is the periodic table, and in the periodic table there are 118 elements. So in this periodic table we have 7 periods. That is first, second, third, fourth, fifth, sixth, seventh. So totally there are 18 groups. So group 1 and group 2, just they belong to the S block. So group 13 to group 18, they belong to P block, where most of the non-metals are present. So group 3 to group 12, they belong to D block. Starting from lanthanum and actinium, there are 14 elements. So this just belongs to the F block. Okay, it just belongs to the F block here. So we have given a table here. So there are accepted 91 metals in the periodic table, and there are 17 non-metals, and there are 7 metalloids. Okay, so the numbers just they vary in some of the books and in some of the browsers. Okay, so the accepted number now it is 91 metals, 17 non-metals, and 7 metalloids. The only non-metal which is present in the liquid form, it is bromine. So bromine is the only non-metal which is present in the liquid form. The only metal which is present in the liquid form, it is mercury. So mercury is the only metal which is present in the liquid form. Next, electronic configuration of elements 1 to 20. So this is the electronic configuration of different elements. So here the filling of electron, it just takes place in accordance to the Aufbau principle. Okay, so here first we will be filling 1s, then we will be moving for 2s, okay, then we will be going for 2p, 3s, okay, 3p, 4s, and so on. So hydrogen has a electronic configuration of 1s1. So one thing you just remember here, hydrogen it is containing one proton and one electron. So it does not contain neutron. Why it does not contain neutron? Because the nucleus of hydrogen, it is very small. It cannot accommodate a neutron within the nucleus of the hydrogen atom. So it is not containing neutron here. So these are the electronic configuration of different elements. Okay. So in the previous year question paper, they have asked what is the electronic configuration of silicon. So just see here, first 1s2, then 2s2, then 2p6. So totally the outermost shell can accommodate a maximum of 8 electrons. So 2 plus 8, 10. So what is the atomic number of silicon? It is 14. So still we require, what is that? The 4 electrons, means 3s2, and here we have 3p2. So the electronic configuration of silicon, it is 1s2, 2s2, 2p6, 3s2, and 3p2. Okay, so dear students, just practice this, so you may get this in the examination. It is very important from the point of examinations. The next is orbitals, that is sp,df. So orbitals andre enu? Orbitals, they are the regions where electrons are most likely to be found. Andre electron ಹೆಚ್ಚಿಗೆ ಸಿಗುವಂತ ಸ್ಥಳಗಳು. So they are not circular paths like planets. Each orbital has a unique shape and electron capacity. So ಇದನ್ನ ನೆನಪಿಟ್ಕೊಳ್ಳ್ರಿ, ಎಕ್ಸಾಮ್ ನಲ್ಲಿ ಕೇಳಬಹುದು. S orbital, what is the shape of S orbital? It is spherical in shape. The shape of the S orbital, it is spherical. ಇಲ್ಲಿ maximum of electrons ಎಷ್ಟಿರ್ತವೆ? The maximum of electrons in the S orbital, it is always 2. So it is present in every shell. ಎಲ್ಲ shell ಒಳಗೆ present ಇರ್ತದೆ. That is 1s, 2s, 3s, 4s, and so on. So it has a simple shape. So it provides high stability. Okay, so stability ಇಲ್ಲಿ ಏನಿರ್ತದೆ? ಹೆಚ್ಚಿಗೆ ಇರ್ತದೆ. So p orbital ಏನ್ shape ಇರ್ತದೆ? It is having a dumbbell shape. Okay, orientation ಯಾವ್ಯಾವ ಇರ್ತಾವೋ? px, py, and pz. Totally there are 3, what is that, orientations. Maximum of electrons ಎಷ್ಟು ಕೂಡಿಸಬಹುದು p ಒಳಗೆ? The maximum of 6 electrons ಇರ್ತಾವ p orbital ಒಳಗೆ. So it starts from the second shell, that is from 2p, 3p, 4p, and so on. Okay, so ಇದು ಒಂದು ಮೇಜರ್ ರೋಲ್ ಪ್ಲೇ ಮಾಡ್ತದೆ ಎಲ್ಲೇ? ಬಾಂಡಿಂಗ್ ಮತ್ತೆ ರಿಯಾಕ್ಟಿವಿಟಿ ಒಳಗೆ. The next is d orbital. The shape of d orbital, it is clover leaf. So exam ನಲ್ಲಿ ನಿಮಗೆ shape of the s, p, d, f ಅಂತ ಕೇಳಬಹುದು. So d orbital shape ಏನಿದೆ? It is clover leaf. So the number of orbitals, they are 5. Okay, so the maximum electrons in this particular d orbital, it is 10. So it begins from 3d, 4d, 5d, that is the transition metals. So ಇಲ್ಲಿ d electrons, they are responsible for color, magnetism, and complex formation ಗೆ ಇವು responsible ಆಗಿರ್ತವೆ. So the next is f orbital. So f orbital shape ಏನಿದೆ? It is somewhat complex and multi-lobed. Okay, so the number of orbitals for f, it is 7. So maximum electrons ಎಷ್ಟು ಇರಬಹುದು ಇಲ್ಲಿ? The maximum electrons, they are 14. So these are found in the lanthanoids and actinoids. Okay, ಕೆಳಗಡೆ ನಾವು ನೋಡಿದ್ವಿ starting from lanthanum ಮತ್ತೆ actinum. Okay, so these are responsible for the unique chemical behavior. The next, it is valency. Valency ಅಂದರೆ ಏನು? valency it is the combining capacity of an atom anta ಹೇಳ್ತೀವಿ. So ಇದು ಏನು ಹೇಳ್ತದೆ, how many electrons an atom can lose or gain or share during a chemical reaction ಅಂತ ಹೇಳ್ತದೆ. So valency rules ಏನು ಹೇಳ್ತದೆ, if valence electrons if they are less than or equal to 3, atom loses electrons means the valency will be 1, 2 or 3. So if valence electrons if they are 5, 6, 7, atom gains electrons means the valency it is 3, 2, 1. Okay. So if valence electrons if they are 8, then the valency it is 0 for noble gases. 18th group elements ಅದರ outermost shell ಒಳಗೆ 8 electrons ಇರ್ತವೆ. ಹಾಗಾಗಿ 18th group element they are the stable elements and they are called as the noble gases here. Okay, so let us try to understand valency 1, 2 and 3. Okay, so just see here dear students, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium. Okay, so here helium is a noble gas, here neon is a noble gas. Okay, so now here this neon it is containing 8 electrons in its outermost shell. Okay, so sodium, what is the electronic configuration? 1s2, 2s2, 2p6, 3s1. Okay, in the third shell it is containing 1 electron. Okay, so sodium wants to become stable. What it should do here? So sodium should lose 1 electron so that it can have 8 electrons in its outermost shell. So sodium loses 1 electron here. So because of that reason sodium carries plus charge. Okay, by losing sodium 1 electron it is stable as that of the group 18 elements. So sodium always carries plus charge. So here what is the valency here for sodium? It is 1 because it is losing 1 electron. So the valency for sodium it is 1. And what is the number of valence electrons for sodium? It is 1. Okay, the number of electrons which is present in the outermost shell, they are termed as the valence electron, and for sodium in the outermost shell there is presence of 1 electron. So the valence electron it is 1 and the valency it is 1 because sodium it is losing 1 electron, so the valency it is 1. So because of that reason sodium always carries plus charge here. So magnesium, so what is the electronic configuration? 1s2, 2s2, 2p6, 3s2. In the outermost shell magnesium carries 2 electrons means it is having 2 valence electrons. So if it wants to become stable, what it should do? It should lose 2 electrons. Okay, if magnesium loses 2 electrons, what happens? It will be carrying Mg2 plus. Okay, so if it is losing 2 electrons, what will be the valency here? The valency will be 2. Okay, so as such here aluminium. So if aluminium wants to become stable, what it should do? It should lose 3 electrons. So always aluminium carries which charge? Aluminium carries 3 plus charge. Okay, so now here dear students, lithium, if it wants to become stable as that of helium, it should lose 1 electron. So lithium carries always plus charge. So beryllium, it will lose 2 electrons, that is Be2 plus. Okay, next boron 3 plus. So carbon is an element which neither loses 4 electrons or neither gains 4 electrons here. Instead they will mutually share their electrons with different elements or the same elements to form, what is that? A covalent bond. So the next is nitrogen. Instead of losing 1, 2, 3, 4, 5 electrons, nitrogen can gain 3 electrons to attain the 8 electrons, that is 1, 2, 3 here. So always nitrogen carries -3 as we have said in the definition here. It can lose or it can gain or it can share the electrons. Okay, so nitrogen always carries -3 charge, oxygen carries -2 charge. Okay, so oxygen carries -2 charge. So what is the valency for nitrogen here? The valency for nitrogen, it is the valency for nitrogen, it is 3. So the number of valence electrons for nitrogen, it is 5. The number of electrons which is present in the outermost shell. So outermost shell ಒಳಗೆ ಎಷ್ಟು electrons ಇದಾವ? 5 electron ಇದಾವ. ಎಷ್ಟು ಬೇಕು ಆಕ್ಟೆಟ್ ಆಗಬೇಕಂದ್ರೆ 3 ಬೇಕು, ಅಂದ್ರೆ ಟೋಟಲ್ 8 electrons ಆಗ್ತದೆ. ಸೊ ಈ 3 ಏನಿದೆಯಲ್ಲ, it is valency. 5 ಏನಿದೆಯಲ್ಲ, it is the valence electrons. Okay, what is the charge here? It is -3. Oxygen gain charge ಇದೆ -2. Okay, so chlorine ಒಳಗೆ ಏನಿದೆ? So 1s2, 2s2, 2p6, 3s2, 3p5. So outermost shell ಒಳಗೆ ಎಷ್ಟು electrons ಇದಾವೆ chlorine ಗೆ? We have 7 electrons, means we have 7 valence electrons. So 8 ಆಗಬೇಕಂದ್ರೆ ಎಷ್ಟು ಬೇಕು? 1 ಬೇಕು. So what is the valency for chlorine? It is 1. Okay, so dear students, this is one of the important concepts. If you have not understood, just comment me so that I can clarify you regarding this topic. The next is octet rule. So atoms become stable. Atoms ಯಾವಾಗ stable ಆಗ್ತದೆ? ಯಾವಾಗ ಅಲ್ಲಿ 8 electrons ಇರ್ತದೆ in the outermost shell, ಆವಾಗ atoms ಏನಾಗ್ತಾವ? Stable ಆಗ್ತಾವ. So atoms ಏನ್ ಮಾಡಬಹುದು ಇಲ್ಲಿ? They can gain, lose or share electrons to complete the octet here. So for example sodium. So sodium ಒಳಗೆ ಏನಿದೆ? So it is having K shell ಒಳಗೆ 2 electrons, okay, L shell ಒಳಗೆ 8 electrons and M shell ಒಳಗೆ ಏನಿದೆ? ಇಲ್ಲಿ 1 electron ಇದೆ. So the atoms which is having 8 electrons in their outermost shell, ಅವು ಸ್ಟೇಬಲ್ ಇರ್ತಾವ ಅಂತ ನಾವು ಮೇಲೆ ಡೆಫಿನೇಷನ್ ಒಳಗೆ ಓದಿವಿ. ಸೊ ಸೋಡಿಯಂ ಕಡೆ ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ. ಓಕೆ, ಸೊ ಅದು ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಲೂಸ್ ಮಾಡ್ಕೋತಂದ್ರೆ ಏನಾಗ್ತದೆ? ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಸ್ಟೇಬಲ್ ಕಾನ್ಫಿಗರೇಷನ್. ಸೊ ದಟ್ ಈಸ್ 2-8. ಸೊ ಬಿಕಾಸ್ ಆಫ್ ದಾಟ್ ರೀಸನ್ ಸೋಡಿಯಂ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಲೂಸ್ ಮಾಡೋದ್ರಿಂದ ಅದ್ರ ಮೇಲೆ ಚಾರ್ಜ್ ಏನ್ ಬರ್ತದೆ? ಪ್ಲಸ್ ಬರ್ತದೆ. ಓಕೆ, ಸೊ ದ ನೆಕ್ಸ್ಟ್ ಈಸ್ ಕ್ಲೋರಿನ್. ಸೊ ಕ್ಲೋರಿನ್ ಏನಿದೆ? ಕೆ ಶೆಲ್ ಒಳಗೆ 2, ಎಲ್ ಶೆಲ್ ಒಳಗೆ 8, ಎಂ ಶೆಲ್ ಒಳಗೆ 7 ಇದೆ. ಸೊ ಈಗ ಕ್ಲೋರಿನ್ 8 ಆಗಬೇಕು. ಓಕೆ, ನಾವೇನಂತ ಹೇಳಿವಿ? ಐದರ್ ಬೈ ಗೇನಿಂಗ್ ಆರ್ ಬೈ ಲೂಸಿಂಗ್ ಆರ್ ಬೈ ಶೇರಿಂಗ್ ಅಂತ ಹೇಳಿವಿ. ಸೊ 2, 8, 7 ಇದೆ. ಸೊ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ತಗೋತಂದ್ರೆ ಏನಾಗ್ತದೆ? ಕ್ಲೋರಿನು 8 ಆಗ್ತದೆ. ಮೀನ್ಸ್ ಇಟ್ ಕ್ಯಾನ್ ಬಿಕಮ್ ಸ್ಟೇಬಲ್. So because of that reason chlorine is having always minus charge. Okay, so this is why atoms either lose, gain or share electrons. Why is argon chemically inert? Because argon in its outermost shell it contains 8 electrons. Because of that reason argon it is chemically inert. The next is Lewis electron dot structures. An extremely simple way to show the valence electrons. Okay, so definition in ಹೇಳ್ತದೆ? A Lewis dot structure shows the symbol of the element, okay, with dots representing its valence electrons placed around it. So for example, if we take, dear students, hydrogen outermost shell ಒಳಗೆ ಎಷ್ಟು electrons ಇದೆ? It is having 1 electron. So hydrogen it is just represented by 1 dot. Okay, so carbon the electronic configuration ಏನು? 1s2, 2s2 ಏನಾಗ್ತದೆ? 2p2. So in the outermost shell carbon contains 4 electrons. Okay, so means carbon is containing 4 valence electrons. So it is represented by 4 dots, 1, 2, 3, 4. Okay, so if we can take nitrogen, so electronic configuration ಏನು ಹೇಳ್ತದೆ? 1s2, 2s2, 2p3. So means in the outermost shell there are 5 electrons, means it is containing 5 valence electrons. Okay, so 1, 2, 3, 4, 5. So this is the Lewis dot structure. So for oxygen, what is the electronic configuration? 1s2, 2s2, 2p4. In the outermost shell we have 6 electrons, that is 6 valence electrons. So electron dot structures 1, 2, 3, 4, 5, 6 totally R dots bartave. So sodium, so if we take sodium, so what is the electronic configuration? 1s2, 2s2, 2p6, 3s1. So what is the number of valence electrons? It is having one valence electron, so it is represented by one dot. Okay, so I think you have understood this concept, dear students. If they ask the question on Lewis dot structure, I think you can just write the Lewis dot structures for different elements. So ಇಲ್ಲಿ ಏನು ಹೇಳ್ತದೆ ಅಂದ್ರೆ the number of valence electrons ಅಂದರೆ outermost shell ಒಳಗೆ ಎಷ್ಟು electrons ಇರ್ತದಲ್ಲ ಅಷ್ಟು electrons ಗೆ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, just we will be representing it in the form of dots. That's it. I think, dear students, every concept is clear to you. So now we will solve some of the questions from KAR-TET previous year questions on atoms. Okay, so practice before examinations. So the electronic configuration of silicon is, okay, so we know silicon, it is the 14th element in the periodic table. So 14 electrons heng arrange ಮಾಡ್ತೀವಿ, 1s2, 2s2, 2p6, 3s2 ಏನಾಗ್ತದೆ, 3p2 ಆಗ್ತದೆ. So 1s2, 2s2, 2p6, 3s2, 3p2. So ಇಲ್ಲಿ ಸರಿಯಾದ ಉತ್ತರ option 1, that is 1s2, 2s2, 2p6, 3s2, 3p2. The next question, the liquid non-metal. So options ಈ ರೀತಿ ಇದೆ. Option 1 mercury, option 2 gallium, option 3 cesium, option 4 bromine. So as we have discussed, totally in the periodic table there are 17 non-metals. So among these 17 non-metals, bromine is the only non-metal which is present in the liquid form. Okay, so here mercury is the metal, okay, which is present in the liquid form. ಇಲ್ಲಿ ಸರಿಯಾದ ಉತ್ತರ option 4 bromine. So bromine is the only non-metal which is present in the liquid form. The next question, it is the maximum number of electrons in M shell. Options ಈ ರೀತಿ ಇದೆ. Option 1 32, option 2 18, option 3 8, option 4 2. So we know, dear students, there is presence of K shell. So K shell value ಏನಿರ್ತದೆ, n is equal to 1 ಇರ್ತದೆ. So L shell n value ಏನಿರ್ತದೆ, it is 2. So M shell, what is the value of n here? It is 3. So according to the 2n square formula, so 2 into m the value ಏನಿದೆ, n value, it is 3. So 2 into 3 square, that is nothing but it is 18. Okay, so the maximum number of electrons in the M shell, it is 18. That is option 2, it is the correct answer. So ಈ ರೀತಿ ಪ್ರಶ್ನೆ previous year question paper ಒಳಗೆ ತುಂಬಾನೇ ಕೇಳಿದ್ದಾರೆ. Okay, so just practice this, it is very important from the point of examination. So the next question, it is transmutation refers to the production of. Options ಈ ರೀತಿ ಇದೆ. Option 1 nuclear compounds, option 2 new mixtures, option 3 isotopes, option 4 electrons. So as we have discussed, atoms undergo transmutation because their nucleus is unstable and wants to become more stable by changing into the another element. So which is nothing but they are the isotopes. ಇಲ್ಲಿ ಸರಿಯಾದ ಉತ್ತರ option 3 isotopes. So friends, I hope now atoms, shells, electronic configuration, valency and the octet rule are crystal clear. ನೀವು ಇವತ್ತಿನ ವಿಡಿಯೋದ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ಒನ್ಸ್ ರಿವೈಸ್ ಮಾಡಿದರೆ ಕೆಮಿಸ್ಟ್ರಿಯ ಆಲ್ಮೋಸ್ಟ್ 80% ಬೇಸಿಕ್ MCQs ನಿಮಗೆ ತುಂಬಾ ಈಸಿ ಆಗಿಬಿಡುತ್ತದೆ. So remember, electrons arrange in shells for stability. Valence electrons decide reactivity and octet rule explains why atoms gain or lose electrons. So these ideas are the foundation for every chapter in chemistry and for every KAR-TET question you will face. So now your next step is simple. Solve the KAR-TET previous year questions I have discussed and check how confidently you can answer them now. And I will also provide a model MCQs in our Telegram channel for the perfection of this topic. So if this session helped you, do like, share ಮತ್ತು ಇನ್ನೂ ವಿಡಿಯೋಸ್ ಮಿಸ್ ಆಗಬಾರ್ದು ಅಂದರೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡ್ಕೊಳ್ಳಿ ಸೈನ್ಸ್ ಪಾಠಶಾಲಾಗೆ. So more high scoring KAR-TET concepts are coming soon. All the best for KAR-TET 2025. You can do it. Thanks for watching Science Pathashala.